right? So let's start with this one, guys. Let's just pick up some typical questions from the last week's SSC CGL all-India mock exam. Here we go. Find out the number of triangles in this figure. You know these questions are usually tricky. I mean, you have to count the number of triangles. Let's see how many of you get the right answer, right? Find out the number of triangles in the given figure. Remember, the best way to answer these questions would be to do numbering so that you don't get confused if you have really counted a particular triangle or not. And elimination is the best technique. So find out that. Let me get back to the question now. So here's the question. It says find out the number of triangles in this figure. So the figure where we have to find out the number of triangles. See, look at each of the, let me look at this piece here, right? If you see in that segment, we have how many triangles? 3 triangles. If you number it as 1 and 2, number 1 is a triangle, number 2 is also a triangle, and the combination of 1, 2 is also a triangle. You're able to follow. So there are total 3 triangles in each leg there. We have chosen only one of the legs, right? We choose only one of the legs. How many triangles did we find? 1, 2 and 1, 2. 3 triangles. And 3 triangles in each of these 4 legs. So that makes it 12 triangles straight. 3 into 4, 12 triangles. 12 triangles are available there itself. Then we have this segment in between, right? Let's name it A, B, C, D. Now how many of these triangles are there? A is a triangle, B is a triangle, C is a triangle, D is a triangle, AB is a triangle, and CD is also a triangle. So how many are these now? 6 more triangles. Simple. 12 here and 6 here. 12 plus 6, 18. And once you've got 18 as the answer, you don't have to worry about more triangles being there or not, because answer definitely cannot be option 1, 2 or 3, right? 12, 14 and 16 are definitely the wrong answers. Answer has to be 18, option 4. Okay. So that's a sitter. Let me move on to the next question. I'm sure all of you got it right. 18 is the correct answer. Look at this one now. A question on paper folding and paper cutting. It says a piece of paper is folded and cut as shown below in the question figures. From the given answer figures, indicate how it will appear when opened. So you know the process, right? We have videos on paper folding and paper cutting. You can just follow that. So there is a piece of paper, a circular piece of paper, which is folded into a semicircle. Then it's folded into a quarter circle. And then these cuts are made. These black things you see, right? These are the cuts. Now for you to answer such questions, the easiest thing to do is, see, I'm looking at the last piece here, this piece here, A, B, C, right? This section. What happened? You have a cut here, right? Then you have a cut here. Sorry. There's a cut. There's this cut, then there is this cut here. Right? There is one cut here, there is one cut here, and there is one cut here. If you observe properly, let me give you an idea, right? If you observe properly, look at this. This center of the quarter, right? This is a quarter circle. Here is a semicircle, here is a full circle. The center has got no cut. The center portion has got no cut, right? On the left hand side of the center there is a cut here. Below the center there is a cut here. And on the arc, there are 3 cuts. There are 3 cuts. Which means when you unfold this, right? When you fully unfold this, the center region has to be intact. You cannot have anything in the center region. Are you able to follow? So I think that's a technique. So if you go by that, here if you see in option number 2 and option number 3, we have something coming up in the center. How can it come up in the center? How can anything come up in the center when here no marking was made, no cut was made? So 2 and 3 are eliminated straight. 1 and 4 are possible, because in 1 and 4 the centers are open. However, if you see in 1 we have only 4 dots. It's not possible, because on this arc itself we've got 3. On the full circle we'll have more than 3. I mean, of course, what happens is when you unfold, this will be combined together on the semicircle there. You understand? On the four corners of the circle, these dots would be there. In addition to this, there will be dots here as well, right? I mean, there will be cuts here as well. So number 1 looks incomplete. So 1 also is wrong. Hence option 4 is the answer. I mean, I'm sure explanation is not required for such questions. It's all observation, right? You have to observe the question properly and mark the answer. So how quickly do you do this is the question here, right? It's fairly easy. You just have to quickly work out and identify the correct answer. And elimination is the technique which works in most of the questions from general intelligence and reasoning. Yeah. Look at this one now. In a certain code language, SUERENIK means she's brave. PISORRENIK means she's always smiling, and SORREZHI means is always cheerful. What is the code used for the word smiling? You have to find out the code for smiling. See, if you look at the common words here, smiling has been used only in statement number 2. There are 3 statements here, right? Statement 1 is she is brave. Statement 2 is she is always smiling. Statement 3 is always cheerful. So smiling has been used only in statement number 2, which means the code for smiling should either be PI or SOR or RE or NIK. All of these have been given the options, right? PI, SOR, RE, NIK. Now, how do you find out the answer? How do you find out the answer? See, look at it. If you look at statement 1 and statement 2, the words she and the words E are common. The words she and the words E are common. So what are the common codes? In 1 and 2, what are the common words? She and E's are common. In terms of codes, what is common? I think RE is common. You see, RE is available in both. And I think NIK is also available in both. So very clearly, she and E's will take up the codes of RE and NIK. Which means smiling cannot be RE or NIK. You're able to follow. Elimination again. We know that she and E's will be taking up codes of RE and NIK in some order. So the code for brave is SUE. Here, the code for always and smiling will be among PI and SOR. PI and SOR. But then again, if you see, always is common between statement 2 and statement 3. And the common code between 2 and 3 is SOR, SOR and SOR. So I can clearly designate always as SOR. The code for always is SOR. So SOR is also eliminated. What is left out? PI. So we can say the code for smiling is PI. Again, a very simple question from this topic of coding and decoding. We have discussed enough of such question types in the past. Yeah. So again, repeatedly, the point that I would make here is it's a very, very easy section. You should make sure that you optimize your score in general intelligence and reasoning and try to score near 50. Let me tell you, it's not difficult. Scoring 50 in general intelligence and reasoning is not a big deal. It's just that you have to be really quick and don't commit silly mistakes. That's about it. What else? I think there's this question on, again, explanation here doesn't really, explanation is not really required, because for such questions, when you see the solution, written solution, you would know what the logic is. It's all about logic, right? So logic need not be explained. If it is written there, you would know. So I'm sure when I'm discussing such questions on general intelligence and reasoning, most of you may feel that, these are all very easy ones. But that's how the paper is. That's how the paper always is when it comes to SSC. Anyway, let's look at this question now. Find the hidden meaningful word from the coded alphabets if the alphabets are in reverse order. So that's an interesting one. Let's see how many of you have got the answer here, or how many of you get the answer here. Find the hidden meaningful word from the coded alphabets if the alphabets are in reverse order. Look at this. Find the hidden meaningful word from the coded alphabets if the alphabets are in reverse order. So basically, alphabets are in reverse order. Like if you write A, B, C, D, E, F, and so on up to X, Y, Z, the positions in the alphabetical order are 1, 2, 3, 4, 5, 6, and so on up to 24, 25, 26. But what will be the positions in the reverse order? This will be 26, 25, 24, 23, 22, 21, and so on. Up to this will be 3, 2, and 1. Okay? The simple logic here is, if you want to find out the position in the reverse order, the simple technique that can be used is, if you observe, the sum of actual position and the position in reverse is always 27. See, 1 plus 26 is 27. 2 plus 25 is 27. 3 plus 24 is 27. 4 plus 23 is 27. 5 plus 22 is 27. 6 and 21 is 27. 24 and 23 is 27. This again is 27. Here again it's 27. So the simple thing that you have to keep in mind is the sum of the current position, the sum of the actual position plus reverse position is equal to 27. Actual position plus reverse position is equal to 27. Just remember this. and it becomes really very easy for you to find out the answers to such questions then. Now what does it say? Find the hidden meaningful words from the coded alphabets. So basically it says this is the 11th letter in the reverse order. Now 11th in the reverse order meaning what will be in the forward order? 27 minus 11. Say 27 minus reverse position. So for me to find out the actual position, what should I do? Actual position will be equal to 27 minus reverse. Just remember this. 27 minus reverse. Yes or no? Just remember that it's going to be 27 minus reverse. This is not a new technique again. I mean, you should know that position from front end plus position from back end will be equal to total number of persons plus 1. Total number of letters plus 1. 26 plus 1, 27. That's how we have got it. So 27 minus reverse. So 11 will be what? 27 minus 11, 16. This is 27 minus 15, 12. This is 27 minus 26, 1. This is 27 minus 13, 14. This 27 minus 22 is 5. So the letters are 16, 12, 1, 14, 5. Now what is the 16th letter? P. What is the 12th letter? L. What is the first letter? A. What is the 14th letter? N. What is the 5th letter? E. Here itself I am getting a meaningful word. P, L, A, N, E, plain. So I think option 1 itself is the answer. I don't have to worry about 2, 3, 4. I don't have to worry about 2, 3 and 4 here because in first option itself I have got a meaningful word. If you want, you can try out 1 or 2 other options. Like if you see 15, 11, 22, 26, 13. 15 will be what? L, right? I mean, we've already found this, so don't waste your time. 15 is 12, so 12 is L. 11 is 16th, so P. 22 is 5, so E. Here itself, L, P, E is not a meaningful, right? I mean, a word starting with L followed by P, E is not meaningful. Similarly, 3 and 4 also will get eliminated. So I think the most important takeaway from this question should be to find out the actual position of an English alphabet. When the reverse position is given, all you have to do is 27 minus the reverse position. 27 minus the reverse position, right? Sum of the forward position plus reverse position is always 27. Yes or no? So here he says it is the 11th letter in the reverse order. 11th letter in the reverse order is 16th letter in the forward order. 27 minus 11. Are you able to follow? 27 minus 11 is equal to 16. 27 minus 15 is equal to 12. 27 minus 26 is equal to 1. 27 minus 13 is equal to 14. And 27 minus 22 equals to 5. That's it. So 16, 12, 1, 14, 5 are the letters, which is P, L, A, N, E. So there itself we have a meaningful word. Yeah. Option 1 is the answer. Try this one now, quickly. If the difference between the number of dots on the opposite faces is 3, then find out the figure which is correct. He says the difference between the number of dots on the opposite faces is 3. So find out the figure which is correct. Alright, here we go. Look at this question. If the difference between the number of dots on the opposite faces is 3, find out the figure which is correct. So what's the logic here? It says the difference between number of dots on opposite faces should be equal to 3. The difference between the number of dots on opposite faces should be equal to 3. Find out the figure which is correct. Yeah. Now look at this. I mean, if you look at the first die, how many dots do we have on the faces shown here? This is 2 plus 4, 6 plus 3, 9. So this is like 9. This is 5. 3 plus 2, 5. And this is what? 5 plus 2, 7. 9, 5, 7. This is 6 plus 3, 9. This is 3. And here we've got 4 and 3, 7. Oh, sorry, this is 8. Sorry, let me just clear it out. Three plus 3, 6 plus 3, 9 here. This is 3. This is 4 plus 2, 6 plus 1, 7. Here, what do we have here? 3 plus 3, 6 plus 2, 8. This is 5. And here we got 6 plus 2, 8 again. Look at the last one. 3 plus 3, 6. This is 4. And this is 5. Now you see, if you talk about a die, you know that the numbers are 1, 2, 3, 4, 5 and 6. Right? He says the difference between the number of dots on opposite faces have to be 3. So what should be the opposite faces? 2 should be opposite to 5, 3 should be opposite to 6, 1 should be opposite to 4. In all the 3 cases, the difference will be equal to 3. Yes or no? Which means, now you know the funda, right? In a die, when you are shown this kind of a figure, one of the angular views, opposite faces will never come together, right? Opposite faces will never come together. So if 5 is available, 2 should not be available, because 2 should be opposite to 5. So 2 is behind that. Yes, 2 is not available here. Yeah. If 6 is available, then 3 should not be available, because opposite of 6 should be 3. So if 6 is here, opposite of 6 should be 3, and 3 should not be available in this figure. Because if 3 is available, then 6 and 3 will become adjacent faces. Yes or no? 3 should be below the under face of this die. Similarly, if 4 is visible, 1 should not be visible, and 1 is not visible. So this looks like the proper dies which will satisfy this condition, right? The difference between the number of dots on the opposite faces is, where is that? Sorry. The difference between the number of dots on the opposite faces is 3. So 6, 4, 5, all 3 are shown, meaning the opposite faces. Say 6, 4, 5 are shown, opposite faces 3, 1, 2 are not shown, right? So option 4 looks like the correct one, right? I mean, these are not standard dies. First of all, option 1, 2 and 3, they've got, these are not standard dies. Yeah. Here we have 9, 5, 7, here we have 9, 7, 3, this is 8, 5, 8. So option 4 has to be the answer. I mean, a setter there. 5 is opposite to 3, 5 should be opposite to 3, 4 should be opposite to 1, 6 should be opposite to, 5 should be opposite to 2, 4 should be opposite to 1, 6 should be opposite to 3. Let's take up the next one very quickly. I think this probably will be the last one. This is a question on assertion and reasoning, right? Assertion and reason. Try this. He says there are 2 statements labeled A and R. A is the assertion and R is the reason. What is A? Autism is a developmental disability. Now you know that autism is a disability, right? The assertion is that it is a developmental disability. It's a developmental disability. And why are they asserting this? The reason given is heredity and lower development of brain are the causes of autism. Right? The lower development of brain. It can be heredity. It means it comes from the kind of parents and grandparents and all, right? And lower development of brain. So when the brain does not develop fully, it can cause autism. And because of this reason, they make a statement that autism is a development disability. Yes, if this is the reason, then we can assert that autism is a development disability. So both A and R are true, right? The assertion is true. The reason for that is also true. The assertion and the reason both are true. I mean, it's a sitter again, not very complex. And again, in general intelligence and reasoning, you don't get very complex critical reasoning questions like what we get in bank exams, right? Like statements and arguments, statements and assumptions, and what, strong and weak statements, all those kind of strong and weak arguments, all those type of questions are not asked here. It's a very simple one. Assertion and reason. You have to see if it is really, true or not true, right? I mean, both are connecting with each other or not. Yeah. So I think that's about it. All others were all simple questions. And the most interesting part is in general intelligence and reasoning, when solutions are given, which are available after you finish your all-year mock exam, you know that from Monday 11 o'clock onwards, you can see the solutions. You can just refer to the solutions to know what the answers are and what's the logic behind the question there. So there is no explanation required as such. Right? However, we'll continue doing one session on general intelligence and reasoning every week and try and discuss more and more interesting ones, more and more typical type of questions, so that you are in touch with your concepts and you can answer your questions very quickly in the exam. Alright? And yeah, I think with this we come to the end of this session, which was for both reasoning ability from your SBI PO Prelims mock exam and general intelligence and reasoning from your SSC CGL Tier 1 mock exam. Sony says, please, one question. Which one question? Which one question, Sony? Oh, Shiti says solve questions from syllogism. Syllogism, Shiti, all your friends have said that syllogism is easy, and I think it's actually easy. So why didn't you try it yourself? Let me take one. I mean, now that you mentioned, let me just take at least one of these questions. Look at this. So regular syllogism type, he says, find out which of these conclusions logically follow, right? So look at the statement, some towns are village. Some towns are village. Some villages are mangoes. Some villages are mangoes. No mango is guava. No mango is guava. Some towns are villages. Some villages are mangoes. No mango is a guava. Now, conclusion number 1. Some villages being guava is a possibility. Yes, some villages being guava is a possibility. See, guava should not touch mangoes, but guava can touch villages, right? Guava should not touch mangoes, but guava can touch villages. So, some villages being guava is a possibility. So, first one is true. All villages being guava is a possibility? No. All villages being guava is not possible, because if all the villages go inside guava, these mangoes will also go inside guava. But we know that mangoes and guava should not touch each other. So only conclusion 1 follows as the answer. Right? Only conclusion 1 follows. Similarly, if you, let's say, take this one. Some pens are papers. Some pens are papers. Some papers are pencil. All pencils are files. All pencils are files. Some pens are papers. Some papers are pencils, and all pencils are files. That's the basic diagram. Now look at the conclusions. Some files are pencils. It's obvious, when all pencils are files, the definite conclusion is some files are pencils. So you don't even have to look at the diagram for this particular conclusion, right? For all A's are B's, the definite conclusion is some B's are A's. So for all pencils are files, the definite conclusion will be some files are pencils. You don't even have to draw the diagram for this one, right? Second conclusion. Some pens being pencil is a possibility. Some pens being pencil is a possibility, yes. There's no negative statement here, so anything is possible. Remember, it's a simple technique. All are positive statements, right? Some A's are B's, some A's are B's, all A's are B's. In such cases, a positive conclusion is always possible. Some pens being pencils is a possibility, it's possible. Pens can be pencils. Only when no A is B, some A's are not B's kind of statements are given, you have to be careful about such possibilities. Otherwise, you can straight away say that this is possible. So in this case, conclusion 1 and conclusion 2 both follow. Both conclusion 1 and 2 follow. Yeah. And here's the last one. All A's are P. All A's are P. All A's are P. Some P's are C. Some P's are C. All C's are R. Remember, this R is not touching A. In the diagram, it looks like it is touching A, but actually R is not touching A. Let me redraw it. Okay. All A's are P. Some P are C. All C's are R. Now conclusion. Some R are A? No. Remember, R and A are not touching. In the basic diagram itself, it fails. This is a basic diagram, right? In the basic diagram itself, some R or A is incorrect, because R and A do not touch each other. So how can you say some R or A? It's wrong. Some P are R? Yes, some P would definitely be R. Only conclusion 2 follows. How can I say some P are R? See, the point is this. We know that some P are C and all C are R. I have told you one technique in earlier live sessions, right? Whenever we have all C's are R, wherever we have C, we can replace with R. Whenever we have all C's are R, like whenever it says all X are Y, X can be equal to Y. X can be simply replaced with Y. See, Y will not be replaced with X. Y cannot be replaced with X, but X can be replaced with Y. This is a technique that you all must remember. When you say all X are Y, you can simply replace X with Y. Wherever you have X, you can replace with Y. But you cannot replace Y with X. Yeah, that may not be true. So here it says all C's are R. Wherever we have C, just replace with R. So I can replace the C with R. So the statement itself becomes some P are R. Yes, some P are R. So statement itself is saying some P are R. Conclusion some P are R will be true. Some P are R will be true. So only conclusion 2 follows. Conclusion 1 does not follow. Only conclusion 2 follows. Option 2. I think very simple, right? Each question would take about 30 seconds, not more than that. 30 seconds and you'll score 1 mark. So it's actually very easy. Like most of you had pointed out, syllogisms asked was very, very easy in the last all-India mock exam. Jay Murli says, is it necessary for the statements to be true in real In banking exams, it would be stated that statements must be considered true even if they are not true in real context. Yes, it is not necessary that statements have to be true, right? I mean, they say, like, look at this itself, no? There's no meaning here. Some pens are papers. How are some pens papers? It's not, the statements will not be true. I mean, it will not be a commonly known fact. It will be, it will be actually against a commonly known fact. It says some windows are dogs. How can windows be dogs? There can, never be a window which is a dog or a dog which is a window, right? No relationship at all. So is it necessary for the statements to be true in real? No, not at all. Kshitiz has asked a question again. He says if any one basic diagram not follows, then we don't take that conclusion as true. Yes, if the conclusion fails in the basic diagram, then it is false. See, a conclusion that cannot satisfy a basic diagram is always false. A definite conclusion, to be specific, a definite conclusion which cannot satisfy a basic diagram is false. Take it straight. It should be true in all the basic diagrams for it to be a true conclusion, right? It should not be true in all the basic diagrams. Basic diagram is only one. It should be true in all the diagrams. There's only one basic diagram, remember? There's only one basic diagram, all others are possible diagrams. So don't confuse yourself by saying it should be true in all basic diagrams. Basic diagram is only one. All others are possible diagrams. So for a conclusion to be true, it should be satisfying not only the basic diagram but all the possible diagrams as well. But if it is not satisfying the basic diagram itself, there itself we can say it's false. Yeah. Okay, I just read one statement. This is the last comment that I'll respond to and then we'll close the session. Rajshekhar says, not able to see the number of questions attempted while taking the test. Please enable this option. Rajshekhar, we got this feedback from some other students also a couple of weeks back and our technical team is working on it. I'm sure in a week or so you'll have a solution where you'll be able to see the number of questions attempted after the test is over. Okay. So I think we'll close it here. Thank you guys for joining us in this session. Keep practicing. If you have any more queries, any questions from these mock exams that you are not able to follow and which I have not taken up, don't worry. You can post it in the discussion forum and we will take it up during our live doubts clarification sessions on Saturdays. Alright. So keep practicing and take very good care of yourselves. I'll see you soon. Thanks.